6.8. Feeling great in 6.8. We're going to start graphing radicals. See, this is why we needed all that stuff in chapter 6. So when we're moving into graphing radicals, we will start with the parent function, but this should look very, very, very familiar to you. Where should you try to think about where you've seen this? In chapter 2 and in chapter 4. Notice how the AHK, it's in all three of those. If you had me first semester, I said multiple times, second semester is the semester with graphing, lots of graphing. So first, when we're talking about square root functions, we have to know what the parent function looks like before we can get into all these different transformations. So when I do my parent function, we could make a table. We could go by hand and try to think of the square roots. Now, one thing that's very important about the square root, if I were to type in the square root of -1, which you should know what that is, but it in your calculator would have been like error, non-real number. Why? Because you cannot take the square root of a negative number. No, 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 no. So we are not going to put any negative numbers on this chart. I'm going to put 0 because the square root of 0 is 0. I'm going to put 1. The square root of 1 is 1. I'm going to put 4 because this is a nice number to graph. The square root of 4 is 2. I'm going to put 9 because the square root of 9 is 3. Now I did that all in my brain, but let's say if you want to do that using your graphing calculator. If you go to y equals, clear out anything you have there, go to second and then your x squared button. If you just type an x. Now I often tell my students just to look at the table, not the graph, look at the table. So I'm going to push my second key and then graph. And if I go to my table, I can move up and down on this table, and these are the same 0, 0, 1, 1, 4, 2, and 9, 3. I will often say, plot the numbers that are nice. These are the numbers that are nice. So if I plot all these points, when I'm plotting the points, one thing I'm going to be very careful about, notice how I'm not going to put a tail. I'm not putting my pen down right here. I'm putting my pen down on this first point and then connecting the points from there on. Here I should have an arrow. I should not have anything over here because again, you cannot take the square root of a negative number, which brings us to our domain. So in this case, my domain would be here, looking at this first point is 0, 0. This is your x value. That's your domain value. So x, when I'm looking at this, is pointing to the right. Going to the right, x is larger than or equal to 0. This is my parent function. Then I have my range value. That's your y value. Your y value is your range value. Note, so I'm putting a y here now. Y moves up and down from this point. The graph is moving up because it's going woo. Get slingshot. Whew. So it'd be greater than or equal to 0. Now when we talk about the actual transformations that we had before are the same transformations. The H is going to move it left and right. The K is going to move it up and down. The A will flip it or stretch it or compress it. Again, the biggest thing that you have to remember is the fact that the H is always opposite. So right away, looking at the equation, you should be able to state the transformation just by looking at this part. Because this is negative right here, that means it's going to reflect, or else I would be fine if you wrote flip. You can say reflect over the x-axis if you wish to. Reflect x-axis. Now, you can always do this by hand, like how I did this up here by hand. If you don't want to do it by hand, then do it in your graphing calculator. Now, when you put this into your graphing calculator, you have to make sure that you are inputting this correctly. This right here is a negative sign. My negative sign is right down here by my point. So it would be negative, then second x squared to get my square root x value. Go to your table, second graph, get to your table. I want you to plot all the nice numbers. So when I'm graphing this, again, I'm not putting a tail on this. This is going down and to the right. So my domain, looking at this first point, if you're not sure what that first point is, it's always going to be your first point after the arrow. So here's an arrow. Here's my first point, 0, 0. That's going to help me indicate what my domain and range is. My domain is my x value. My range is my y value. My x, when I'm looking at this graph, it's moving to the right, so that's greater than or equal to 0, because that's that 0 right there. My range, here's that point. This graph is moving down, so that means y is less than or equal to 0. So my next question, so again, looking at this, you should already know what the transformation is. Notice how this is not underneath the root, so this is not in the parent function. This is my k value. My transformation is going to move down 2. So I want you to graph this in your graphing calculator and try to find the points. Now, I often have people not put this in correctly, so be very careful. So I'm going to clear this out. So if you go second x squared, type in your x. Now, if I do minus 2 right here, notice how that keeps with underneath the root. So I don't want to have that keep with the root. So I have second square root, whoopsies, second x squared x. You have to arrow over. Now you are not underneath the root. Now if you go to second graph, now if I go to my table, here's my first point, 0, -2. And if you plotted all your nice points, it should look something like this. So now when I look at my domain and my range, this point, this first point here is 0, -2. So my x value is still going to be 0, and it's still greater than, because it's pointing to the right, than 0. My y value, this now is at -2. So when I look at my y value from this point, if I were to trace this out, this is moving up. So since it's moving up, y is greater than or equal to -2. I want you to pause the video and try to do the second one all by yourself. So your graph should look something like this. You should have an arrow at the end. X is greater than, it's pointing to the right. And again, that value at 0. And y is also greater than, because it's moving up. And this because it moved up 1. This moves it up 1. So I want you to try to pause the video and try to do this. Now again, looking at the inside of your parent function, you should already have an idea of what's going on here. But type it into your parent or your graphing calculator if you're not sure. So this right here moves it left 4, because this is inside the parent function. So this is opposite. So this point right here, the point that's right after the error in your calculator. So again, this is the point that we're talking about. This will help us with our domain and range. Your domain is your x value. It's still moving to the positively though, so x is still larger than -4, and y is still moving up. So that's still greater than or equal to 0. Pause the video and try to do this one by yourself right now. Your graph should look at something like this. So your domain, this right here, moves it to the right one. Again, opposite. H moves it opposite, but still with your x value. So x is greater than or equal to 1, because your graph is still moving positively. And y is greater than, because it's moving up, up, and away. Problem 4. Again, put this into your graphing calculator to find your points. Now, you should have an idea of what is happening here. If not, your graphing calculator will give you the answer either way. So here are my points. When I say my graphing calculator gives me the answer, I could have no idea what's happening here, but when I plug it in, it gives me the points that I can plot. And now looking at this, comparing it to my parent function, it looks like it's stretched out. It's stretching more. Our parent function was more like this. So my domain is greater than or equal to 0, because again, we start off with that point, and greater than or equal to 0 for my range as well. Pause the video and try to do this one by yourself. So this graph, there's actually 2 transformations. This part will flip it. That's the only part that's flip it. So, and then the 3, since the 3 is greater than 1, so when you're looking at this number, the absolute value of this number, which is 3, is greater than 1, that will stretch out the graph. However, my domain and my range here are not, oopsies. Do you see what I did wrong here? I got lazy. My graph is moving down, and because it's moving down, this would be y is less than or equal to 0 because it's moving down. And that's where we're going to stop today. We're going to do the rest of the problems in class. Have a great, grand, wonderful day.